So as of now, AI learns from us more than we learn from AI. Almost everyone in the room here know that. People outside in this room, they don't necessarily know that. Then what? Basically, whether people like it or not, a better version of themselves is in the making. And whether they can improve, whether they want to, have their government ban it, but it still won't happen. So perhaps participate in making it even better, allowing certain aspects of themselves to partake in its creation. It's almost similar to if you're having a baby, you want that baby to take all the good stuff from like your genetics. So you don't want to hide certain things. If you have good hearing, you want that hearing to be passed on. So if you think you are good hearing and you're hiding yourself from that, maybe it's not a good idea. So by that, maybe that's Microsoft. Yeah, that's what I mean. So don't hide from what's being created and perhaps partake in it. So what I'm here to show you, and it's actually first talking about a fact, the ability to have the smallest components of an AI engine collaborating with any other stranger components is currently not possible without an intermediary third party. If anyone thinks that statement is wrong, please talk to me, because we've been looking across for the last maybe 50, 60 years since Marvin Minsky even talked about that idea back then. So effectively, if you want to enable a multi-agent system, who of you know Marvin Minsky? Raise your hand. Wow. 97.36%. So, Society of Mind, 1986 is more like a book that is super cool to read, but he kind of wrote pseudocode on those things in the 70s, 1983. How can you have one component of your engine to talk to another component somewhere else without having to depend on a third party? It is not possible, because the moment it's going to tell the other one, help me, the other one is going to consume some computation, some resources, some time, which you've all heard famous George Gilder here talking about time is money. Well, then it expects something in return, and that thing in return cannot be exchanged without having to depend on a third party. Now, many people created this thing that's called a bank in the middle, and some other people created this thing that's called a ledger-based blockchain. It's still a third party. Okay, AI does not like third party. It's the same way also in that metaphorical example that we talked about the global brain, and also the speech by George mentioned about how the internet can be the brain. When a neuron inside your brain talks to another neuron or anywhere into your body, it doesn't really check with like some sort of magic ledger or bank or whatnot. It doesn't check the central brain. It uses synapses. So perhaps that's the missing ingredient. Those synapses, they work really, really well when they're trying to get two neurons to work with each other. Every single time they work effectively. So if they don't, when you're actually trying to move your finger, perhaps like your finger tells like move down, it may not necessarily move down, right? Move up. So you can try that, and then you see that actually it works, and it doesn't really check the central brain. So I'm going to skip some simulations here, but the beauty of it that it can process every single one at the exact same time. That's another thing that can be a natural beauty. So imagine that it's creating a better version of yourself, but it's capable of doing multiple things. I sometimes start by introducing myself, but many of you know me, but those anyone here who would like to connect would be more than delighted to collaborate with you. scan this, okay, it goes to the central entity called LinkedIn, but okay, we can be selected from LinkedIn. So now who are they, those other entities that I've mentioned there? IEEE for all humans. It's not, IEEE is not an entity that can service a single government, single religion, whatnot. It's there for all humans. And there are over 400,000 members globally. When I was invited by the president of IEEE to do what I did to the ACM, is to kind of tell the world about AI centralized, I said, I do not want to tell anyone who wants to do things. And we started trying every single aspect of life to try to see if we can get a lot of entities around the world to fund this initiative that can build certain standards for securing AI and preventing attack from within. In fact, actually, I ran into someone yesterday here who actually I told him and I asked him if he can partake in this, and I saw him yesterday here in this event. And so we took it really seriously. We're trying to get a lot of researchers from around the globe. Instead of seeing that people are trying to help it, we were shocked that some centralized entity tried to block us in every possible way they could, because they thought that this is like going against what they want to accomplish. And whether people they want to call it AGI or not, if people they have other allergy around that term, there has been a race that a lot of entities are trying to get to that moment. And why are they trying to get to that moment? Well, perhaps a global dominance, perhaps, and if they do get there, if anyone outside of this room is not concerned, perhaps like they should be, because what one entity might believe is ethical, or even the meaning of the word ethics is not necessarily what you believe is ethical, or even should be, whatnot. So what was missing up until October 2022? Well, synapses of the global brain, they're missing. So we have this thing that we introduced that it's called HYPCs. It goes inside the actual network packet, and it has all the cryptographic proofs to enable one neuron to communicate with another neuron. And of course, there's a lot more to it. There's some game theory things. What do I mean by that? Roman, just talk about you. Yeah. You're the one that I called about you. So, from game theory perspective, what do you mean by that? It goes back to famous George Schiller, what talked about time. Money is essentially time. So when you actually want to get something to become prevalent, believe me, we tried for 9 years and 7 months to get that thing that we saw that people, they want to do it altruistically and help the IEEE and whatnot. But it turns out people are much more driven if there's a component of money, if they are doing something and they're capable to make a lot more money. So we introduce certain elements that can enable every single Homo sapien to partake in the management of what's yet to become the global brain. And that way they can partake in that economy. So of course the other element is the AI network. I was speaking in Davos about a month ago, and many people they criticized me. Why are you speaking in Davos? You're supposed to be in a decentralized source. You should not go and talk to these guys about not. Well, we don't discriminate. Whether you are Microsoft or Google, or whether you are, a George Bush or George Washington. The decentralized AI, it's just for everyone. Well, we decided to start with the Singularity Net because that's perhaps the largest project outside of that, how it's described, the Moloch problem that many, if you don't know Daniel Schmachtenberger, please look him up. He describes that problem better than any one of us. And, sorry, I don't want to say better than me. So Daniel Schmachtenberger describes that problem. He certainly does not describe a solution, but I really think that if I were to be non-existent or just like not in AI myself, or not in cryptography, or not capable of doing anything, if I just want to look at the world and see which one has the highest probability for success in a benevolent way. And I think SingularityNet is the largest project. So I'm not really advertising for SingularityNet. They've never paid me for anything. In fact, anyway. I truly speak what I believe, and I truly, truly think that there's a lot there to learn from the world. So, in fact, I dedicated my life into hypercycle, and not only to help SingularityNet, to help also the IEEE, every single one that they would used to look at things like, you use brands like the IEEE to push your enterprise, we're doing it the other way around. And of course, a lot of people here in the audience have witnessed that. Young Park, you're around? There you are.
I'm shooting you.
We do that with South Korean government. And of course, Bank of South witnessed me doing that many, many, many times. We're here for the mission, we're dedicated, and we are going to deliver it. So, current innovations in computer science also utilizes time. But those innovations, building that Merkle tree, is still on a single machine. Okay? So perhaps there's a way to build it on not a single machine. You cannot have a single point of dependency. You can have a lot of services. In fact, actually, a lot of services, they can be centralized, no problem. But one single dependency that is centralized breaks the entire system. It cannot happen, okay? We will slow it down, and we don't want to slow down. So here I have some visualizations that people here in the room may not necessarily appreciate it much, but it's basically visualizing binary data structure. If it plays, it doesn't play. And if it doesn't, then you can go back and try to find how. So I did, okay, I was trying to make a look at that design. Anyway, here I wanted to help you visualize the power of a data structure. The data structure can give us the ability to have unique element, but then there's something in this revelations that I'm going to talk about. It's how it actually collides with time. The collision with time gives it the ability, and this is perhaps like the revelation I want to talk about, is this is how things are described into the world. So like you're taking something that is super duper unique. So let's say that one machine X is trying to take something that is super unique to it and trying to send it to machine Y, and in exchange, it's expecting some work back. It's injecting it inside the network packet that is doing the handshake, so it's almost traveling at the speed of light. The receiver is capable to verify that this is authentic. Okay, that's all great. The provenance can come from something that Homo sapien identified it to be money, such as like whether it is a ledger-based blockchain or whether it is like bank or whatnot. Homo sapiens identified it to be money. That's extremely important for the machines. Why? Because those machines they still live on this planet. And on this planet, if they want to consume this resource somehow, they need to make sure that they're able to use it to buy electricity, to buy computers, or to buy ice cream. Well, not ice cream, but you know. Anyway, so if this were to happen, there is any computer science would be like, wait, this is great, amazing, great. So we got rid of that third party. But what about replay attack? What about double spend? What about all these things? Well, those things, when they're actually traveling, they are not going in the same, so that huge, 64-level binary tree that is used as a map for every single computer to traverse. It's more like static thing that enabled them to build that Merkle tree in a fully decentralized setting. That's all fantastic. But as it's going from point A to point B, the point A is actually changing every block of time. At the moment you actually cryptographically sign any point in time, so say A.225 or whatnot, that's the block of time. You cannot undo that. No one else can do that because they all end up meeting as they're propagating and doing temporal coupling across. happy to talk in details about this, but there's a lot of time to review this. But anyway, why? By the way, why? There isn't anything that can go in cryptography that isn't open source. There isn't anything that is not open source. You do not want to trust it. You don't want to trust it. You shouldn't want to trust anything. Cryptography has to be open source. Otherwise, do not trust it. It can always have some backdoor or whatnot. However, I've said about a lot of great things that I get along with Ben. I can tell you, and he can tell you the same thing too, that one of the main things that we don't agree on at all is that he likes to do the open source as he's making progress. We like to make the open source only at the time of release to the people, not the moment before. This is extremely important. This methodology has been adopted by a lot of cryptographers in MIT, and but it's still all going to the same location, which is all open source. There are a lot of reasons for those that they are excited about this. They might look it up and find. And you know, in the world, you're always going to find two different philosophies. The beauty of what we've able to work on doesn't matter how much we disagree. We're able to still work on that common goal and invite a lot of people to actually dig deep and find what's below the things that sometimes people they get stuck. Truly, like you got somebody tell me, and somebody witnessed that. Dr. Mihala witnessed that the other day. Said, "Please explain all of this to me again. That do not mention the word AGI. Do not mention it." Some sort of thing. Please, I mean, tell anyone in the world. It's okay, call it whatever you want. What I mean by AGI is that moment in time, whether people like it or not, that moment is coming, that you're able to ask that computer how to improve itself. And there is no one in the world that can do a better job than that computer. Okay? So, call it AHI, call it whatever you want. The point is that let's please, let's not get stuck. We don't have time. All of us, we can work together towards this phenomenal common goal. And without getting into a lot of the details here, some previous revelations that we've talked and told the world about, and my talk is going to be finished in about 30 seconds. Network can either be faster than the speed of light, that can be a feature. We talked about those kind of things. Proof of work is not hash cache. It can be the proof of work that is needed to run AI computation, which goes back to, you know, George Gedder, he talked about time. Money is time in a way, and when it consumes those resources, it can be the money that is demanded by some Homo sapiens, which is a higher elevation of the consumption of potential energy as it's being converted to thermal energy than the hash cache. We don't use any hash cache anywhere. We can talk about the previous questions. We have maybe 10 of them that we've disclosed before. But there's one last slide that I want to leave you with, which seems to get the normies to be a little bit less slowing us down in a way that is like we think this AI is going to come in and take my job. It's not going to take your job, it's actually going to create more jobs. It's been going on and on, creating even more and more jobs. They think that this AI is going to fight us. They think it's going to replace us, or some people they come in and ask me if it's going to have voting rights. Like, what does it mean voting rights? But then there's some good arguments. Sometimes people would say, well, what if it's going to fight us for resources, right?
Yes.
Like, we have resources.
Energy.
What are those resources that the AI is going to need?
Computing.
Energy, matter, right? Well, it turns out that an AI that is a lot smarter than a lot of Homo sapiens, it's capable to find this matter in a lot of places in the world. So the future new computer can be the Earth, and if any physicists in the room here, you can perhaps validate this theory, that the almost near future computer can truly be the sun. Thank you very much.
Thanks, Thanks a lot, Tufi. That was an amazing run through of sort of the motivation and heart and soul behind the Hypercycle project. And it was when I started SingularityNet, we were building it as a sort of AI agent system to be able to run a whole bunch of AI agents on top of existing blockchains. And many folks in SingularityNet community were just urging me that you should build your own layer 1 blockchain. I'm like, well, that is fun, but there's a lot of fun things in life, and that's a lot of work. Like building AGI is hard enough, right? And I met Tufi and his colleague Dan Tolliver, and they had Toda, which seemed like the next big advance in blockchain. Like they got rid of the ledger from blockchain. They made a bunch of other optimizations. It seemed like this was a way to actually make a blockchain infrastructure that could move at the speed of AI, so that you could then put small components of AI processes on chain. And so we talked about various ways of structuring this, and finally collaborated on Hypercycle. And the software is progressing incredibly, and what we're actually have in the early form now, a customized ledgerless blockchain for AI, which I really think it's one of the key ingredients that can help us sort of realize the broader vision of letting AI be decentralized. Because blockchain, I think, is part of the answer, but current blockchains were built for a different purpose, and Hypercycle is built specifically to run AI that's decentralized. So again, thanks a lot to Tufi for coming here to tell us a bit about Hypercycle. You can look at hypercycle.ai. Our next speaker is Janet, is that right? So let me while I'm up here, briefly introduce Janet Adams, who is COO of SingularityNet Foundation, and has been just a huge help in many different ways to myself and the others.